What's up, guys? Welcome to Chemical Names and Formulas with none other than myself, David Proietti. Now, before we get started, we're going to go over a few things with the periodic table. When naming chemicals and their formulas, the periodic table is very important, especially with metals and nonmetals. To the left of our orange shaded staircase, those are all metals and transition metals. To the right of the staircase are all nonmetals. You'll want to remember this when naming chemicals and their formulas. Now, let's get started. We're going to start off with nomenclature. It may sound like a difficult word, but it simply means to name something. There are two different ways to use nomenclature, for covalent compounds and for ionic compounds. First, we're going to start with covalent. Now, when using covalent, you must always remember that it is between a nonmetal and a nonmetal, so two things to the right of the staircase. When naming covalent compounds, you must use prefixes. The prefixes are as follows: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. These prefixes stand for 1 through 10. And last but not least, you must always remember to use IDE endings. That means chlorine would be chloride, fluorine would be fluoride, phosphorus would be phosphide, etc. Now we're going to go on to naming ionic compounds. When naming ionic compounds, you must always remember that it is a metal and a nonmetal. So one element to the left of the staircase and one to the right. Unlike covalent compounds, when naming ionic compounds, you do not have to use prefixes, so mono through deca are worthless here. Transitional metals are used in ionic compounds, and what this means is that you must always use Roman numerals. That means the stock system. So, for example, iron could have a +2 or a +3 charge, so you must use Roman numerals to specify what charge you are using. And just like covalent compounds, you must remember to use IDE endings. Let's go into a few examples. First, we're going to change a chemical name to its formula. We're going to start with titanium 2 phosphide. Now, the Roman numeral 2 in titanium means it has a +2 charge. That is the stock system being used, like I explained earlier. Phosphorus, if you look in the periodic table, has a -3 charge. Therefore, when balanced, the final formula is Ti3P2. Now, you may wonder this. There are 3 titanium ions with a +2 charge, which equals 6. And there are 2 phosphorus ions with a -3 charge, which equals -6. 6 plus -6 equals 0. When it equals 0, that means it is balanced and correct. Let's go on to our next example. Potassium acetate is going to be our next example. Potassium is in the first column of the periodic table in the alkali metal category and has a +1 charge. Acetate, or C2H3O2, has a -1 charge. Because of the offsetting charges, the balance formula is KC2H3O2. Now, 1 ion of potassium with a +1 charge equals 1, and 1 ion of acetate with a -1 charge equals -1. 1 plus -1 equals 0, meaning this is correct. Our next example is dinitrogen pentoxide. Remember, the prefixes are being used here, meaning it is covalent. That means one of our 10 prefixes must be used to name the number of atoms in each element. Di means 2, and penta means 5. Therefore, since the di is with the nitrogen and the penta is with the oxygen, the final formula is N2O5. Our fourth and final example of changing a chemical name to a formula is sodium fluoride. Sodium is an alkali metal just like potassium, so it has a +1 charge. Fluorine is in the 17th column of the periodic table and is a halogen, so it has a -1 charge. Due to the charges offsetting of +1 and -1, the final balance formula is NaF. There is 1 sodium ion with a +1 charge and 1 fluoride ion with a -1 charge, and 1 plus a -1 equals 0. Now we're going to change chemical formulas to the names. We're going to start off with NaOH. Na is found in the first column of the periodic table, and it is called sodium. OH is hydroxide. Na has a +1 charge, and hydroxide has a -1 charge. So the two of these put together form sodium hydroxide. Next is going to be Fe3PO4 Now, iron, or Fe, is a transitional metal and can have either a +2 or +3 charge. Phosphate, PO4, has a -3 charge. Because there are 3 iron ions with a +2 charge and 2 phosphate ions with a -3 charge, the formula is balanced and is called iron 2 phosphate. Notice how I have the 2 in parentheses using Roman numerals. This is because iron is a transitional metal and the stock system must be used here because it could have a +2 or +3 charge. Our next example is going to be CuO. Copper is another transitional metal just like iron. Therefore, it can have either a +1 or +2 charge. Oxygen always has a -2 charge. Because these charges are offset in the formula, the copper must be a +2, and the final the formula would be called copper 2 oxide. Notice how I also use the Roman numerals in 2 here to show that copper 2 is being used and not copper 1. Our final example is CO2. Carbon and oxygen are used here. Carbon is a nonmetal and has a +4 charge. Oxygen has a -2 charge. 2 oxygen ions and 1 carbon ion balance the formula, forming carbon dioxide, because 2 times -2 equals -4, and +4 plus a -4 equals 0. Thank you for watching, and I hope you enjoyed learning how to name chemicals and their formulas.